Hello, welcome back all of you. How are you? I hope all of you are doing well. Today we're going to do the topic on limits. This is a very important topic because if you understand this concept very well enough, then the understanding the concept of derivatives will not be difficult at all because it's based on limits only, and then that will definitely help you with your problems in physics also. So it's not a very complicated topic, it's a very simple topic. It's just that we need to understand what it is exactly. Okay, and I'm there to help us, to help all of you. So let's try and make this easy for us. So, all right, limits. Now, see, this limits is a very interesting topic, concept. So, when we have equations like 2 plus 2, that's actually a 4 constant values, 4 plus 6, that's actually 10. Now, limits, right from the beginning, I just want to tell you, limits is basically not about that, okay? Limits is actually what is going to happen if that happens, what is going to happen if that changes. What will happen if you move towards that, what will happen if you move towards that. So that's basically the concept about limits. It's not about 6 plus 4 is equal to how much? 10. So limits concept is generally not about that. Okay, let's see what I really mean. Now if we assume a function that is f of x, let's say a function x squared minus 4 by x minus 2. Now what will happen to this value of the function at x equal to 2? At x equal to 2, what will happen is f of 2, that's going to be 2 square minus 4 by 2 minus 2. So 2 square is 4, 4 minus 4 is 0. So what we have here is 0 by 0. Now this is something which is actually not accepted in mathematics. This is something which we call actually meaningless, because you cannot divide nothing by nothing. We cannot express nothing with respect to nothing. So 0 by 0 actually in mathematics we say it's meaningless, or in other words we call this as indeterminate. That means something which cannot be determined, no? Indeterminate form. So 0 by 0 is actually not accepted. That means this function at x equal to 2 does not exist. There will not be any particular value. So that means then definitely what will happen at x not equal to 2. So maybe we'll just simplify this function a little bit more. So a square minus 4 can be written as 2 square. The same function. Okay, we want to find out what happens when x is not equal to 2. Because if x is equal to 2, we have not defined, we cannot solve this function. So what happens if x is not equal to 2? So x plus 2, a square minus b square. X minus 2, so we cancel. So this function, what we have is x plus 2. Alright, at x equal to 2 was meaningless. So at x not equal to 2, or maybe we just simplify the function a little bit, because here what we're going to find out is, we can do it here also actually, about the concept that we are actually trying to discuss. But let me just finish. Let's just finish this. So I've just simplified this. So this function actually at x is not equal to 2, what we have is x plus 2. Our function in the beginning was x squared minus 4 by x minus 2. So at x not equal to 2, our function, after simplifying of course, just for our sake, x plus 2. Now at x not equal to 2, see, if at the number line what happens is, there are two ways. I'll just use only two values. There are two ways to approach the value 2, that is one from the right hand side and the other from the left hand side. That is, from the left hand side we can approach 2, and from the right hand side also we can approach 2. But we know that this function at x equal to 2, which is also this function at x equal to 2 is not defined. The first function, that is x minus 2. This one is just a simplified form at x not equal to 2, because at x equal to 2 it cannot be defined. So we have here 2, this value. So we can approach the value of 2 from the right hand side and from the left hand side. Okay, please listen to me first. After that, once this is over, actually what we are trying to do here, you will understand. So now you might be a little bit confused. Just leave that aside. Let's talk about this. So there are two ways to approach 2 on the number line, from the right hand side and from the left hand side. So let's say we approach from the right hand side So we try to get as close as possible. So maybe we start with, let's say, 2.4, 2.3, and then we try to get closer. Okay, let's say 2.1. Then from the left hand side we try to approach, let's say, 1.9, 1.8, maybe 1.4, no, something like that. So let's see what happens to the value of the function as we approach f from 1.4 towards from the left hand side. So in that case we'll have 1.4 plus 2, so that's going to be 3.4. What about at 1.8? 1.8 will be 1.8 plus 2, that's 3.8. What about at 1.9? That's going to be 3.9. What if we get closer to it again? So more closer. So 1.99. So that's like 3.99, isn't it? 1.99 plus 2, that's 3.99. Okay, a little bit more closer. 1.999. What do we go? 3.999. So that means, like, the more closer we go towards 2, we can see where it is going towards. Alright, let's leave this here. Let's go to the right hand limit. That's like f of 2.4. So 2.4 plus 2, that's 4.4. F of 2. I'll just go straight. 2.1, more closer. That's going to be 4.1. Okay, let's try to get closer to this. 2.01. More closer towards 2. 2.01, you'll have 4.01. Okay, a little bit more closer. 2.001. So that's like 4.001. Now, do you see an interesting thing that is happening here? You see an interesting thing that is happening here, that is, like, when we approach 2 for this function from the left hand side as well as from the right hand side, you will see that as well as from the right hand side also, from the left hand side also, the more closer we get to the value of 2, what happens is we are approaching the value 4. We are actually approaching from both sides. As we approach towards 2, we are approaching the value 4 for this particular limit, isn't it? And that is exactly what actually limits tells us about. Limit doesn't give us a fixed value. It's not about a fixed value that 2 plus 2 is 4. 6 plus 4 is 10. It's not about that. Okay, limit is actually about what will happen to that particular function. It's not every time about 0 by 0 also. But the concept is just about that. No, like what happens, we can even use with only this also, no problem with that. This is just about algebra of limits. We will discuss about that also again. But maybe even if we just start with this x plus 2 also, then is like as x tends to 2. So this is like, in other words, as x tends to 2. Alright, as x tends to 2, or in other words, as x approaches 2 from its left hand side. As x approaches 2 from its left hand side, f of x tends to, so as we were approaching towards x from the left hand side, the value of our function was tending towards which particular value? Towards 4. Similarly, that is like 2 minus, we say. Okay, so this is like not 2 minus. Okay, the meaning of this is like as we approach 2 from the left hand side, no, as x tends to 2, as x approaches 2 from its left hand side. Many still confuse it with like, okay, 2 minus, so that's like 2 minus means, okay, that negative value. No, it's not about the negative value here that we are talking about when we talk of limits. It's about the direction through which, from where we are approaching. So here 2 minus actually represents you're coming from the left hand side towards a particular point. You're coming closer and closer and closer to that particular point, and then finding out exactly what is happening to the value of the function. Where is it actually tending to? Where are they approaching towards? So from the right hand side also you come, left hand side also you come, and check what is happening to the value of the particular function. So both of them will be approaching towards a common value, but not at that point. We are not, in other words, we are not interested at that particular point. Here, primarily, you can just imagine, we are just interested in what is going to happen. Something like that. We are just interested in what is going to happen to this particular function as we approach a particular value, maybe x equal to 2 from the right hand side, from the left hand side, what will happen to the function? So our answer is okay. Right hand side you come, left hand side you come, left hand side you come, right hand side you come closer and closer and closer, the value of the function is going towards nearer and nearer and nearer and nearer and nearer and nearer towards 4, not 4. Okay, we're not talking about that particular value 4. So we just, in simple words, we just want to know, okay, what is going to happen to that particular function as this value goes towards that. So it's something like that only. Okay, as it approaches, what is happening to the value of the function? Alright, where does it tend to? That's what our primary concept is. And from the right hand side, when we approach, we just write x as x tends to 2 plus. That is, as x approaches 2 from the right hand side, f of x, again here also it was tending towards 0. So this is called what we call the left hand limit and the right hand limit. Okay, this is what we call the left hand limit and right hand limit. So in short, we can also write thus the limiting value of the function, as x tends to 2 from the left hand side, that's how we read it, is equal to 4. So actually, again I repeat, it's a bit confusing to understand, but this equal to 4 doesn't mean it is equal to 4. I hope you got my concept, isn't it? It is just telling us that, I'll just write here, as x tends to 2, this is what it's saying, okay, as x tends to 2 from left hand side, the value of the function f of x, are approaching or tending 4. The value of the function are approaching or tending towards or tending to 4. That's what it means. It's not like equal to. Exactly how we read it is the limiting value of the function as x tends to 2 from the left hand side is tending or approaching towards 4. It's not is equal to 4. No, it's, again I repeat, it's not like limiting value of the function as, so this function as we approach 2 from the left hand side will be equal to 4. No, it's not like that. Okay, it is will also tend towards 4 as we approach the value of the function towards 2 from the left hand side. The function, the value, the output will approach towards 4. So this is very important. When we go to differentiation again, we will be discussing that. Similarly, if we approach from the right hand side, that we call, of course this is written like LHL in short sometimes, left hand limit. Okay. And what about the right hand limit then? Definitely right hand limit, of course, approaching a particular function from the right hand side. Right hand limit, that is from the right hand side, that means from the positive, not positive side, from the right hand side, will be as x tends to 2. Remember, this 4 actually came from the function, not every time 4. Okay, we're just talking about the function as we were trying to find out what happens to the function as x tends to 2. So as x tends to 2 from the right hand side, the value of the function are tending or approaching towards 4. So that's what we mean, left hand limit and right hand limit. And then another concept that we have is the limiting value of a function as a whole. Now, the limiting value of a function, that's it, the limiting value of a function as x tends towards a, any point, a can be any point, will exist if the right hand limit as x tends to approaches a from the right hand side is equal to the limiting value of the function as x tends towards a from the left hand side. If both of them are equal, then we say that the limiting value of the function as x tends towards a particular point will exist. That means only when the right hand limit or the left hand limit is equal to the right hand limit. That means that means that function that we had, f of x equal to x plus 2, that limit actually exists, because what we have seen there is that from the left hand side as we were approaching, it was approaching 4. From the right hand side, as we observe, we were studying, it was also approaching 4. So from the left hand as well as from the right hand side, both the value of the function as x was tending towards 2. That was our point 2. Here, of course, we have just taken the general point A. So as x tends to A from the left hand, right hand limit, the limiting value of the function tends towards 4. So that means that a function actually exists. So that is what it means. But sometimes, like a function, same point as it approaches 2 from the left hand side, okay, in this direction. From the right hand side, okay, in this direction, in the upper direction. So in that case, what happens? They are not going to be coinciding at all. So they will be said to be, they do not, that particular limiting value of the function does not exist. Alright, so that's exactly what it means. So this is the simple concept of limits. Okay, so as I said, it's not a very difficult concept, limits. No, it's a very simple concept. It simply talks about what will happen when a value approaches towards that, what will happen when a value approaches towards that direction, towards that particular value. So that's about limits. So based on that, let's just try to solve one question, that is evaluate. I'll just write it in short, left hand limit and right hand limit. Now here we are going to study on how to evaluate limits also. That is also going to be very important. Okay, how to evaluate them. So I haven't given you the algorithm and the steps, because with this example we are going to do one by one exactly how do we calculate mathematically the left hand limit and the right hand limit. So as x tends the function of x, 1 plus x square and 2 minus x if x is greater than or equal to 0, less than 1, and if x is less than or equal to 1, greater than 1 at x equal to 1. And then we also have to show that the limiting value of this function as x tends to 1, because at x equal to 1 does not exist. So does not exist simply means that your left hand limit and your right hand limit will not be same. Alright? Okay. You have written, you can pause the video and write it down. I'm going to rub it off. So now how do we find out the left hand? Let's start with the left hand limit. Okay, so the first step that you write, very simple, that is left hand limit means limiting value of the function, right? As x tends to, what is our point here? 1, isn't it? At x equal to 1. As x tends to 1 from the left hand side. So that's first thing that we have to write, whatever be the point, isn't it? Now the second step is we now see, the thing is, in that previous problem we experimented with different values, x plus 2, so we experimented with 2.1, 2.4, 2.1, 2.4, 2.01, we approached 2.001, 2.001, so we approached more, and limiting value, this will give us more accurate values if the interval is more smaller. That means like that's in the beginning, towards when we were discussing about 2, from value 3 when we were approaching 2.8, 2.7. So when we were talking about that for that particular function, at 2.7, 2.8, actually we were not getting very much clear ideas where it was really approaching, when the points were very far, 1.1, 1.2. So we were not getting a very clear idea exactly where the point was approaching. But as we were getting closer and closer towards 2, let's say like 2.1, here let's say 1.9, then we were getting some idea, okay, there's like 3.9, 4.1, and then as we were again getting closer and closer and closer and closer towards 2, we almost could make out that, okay, this is approaching towards 4, because it's getting closer towards 4. Which means that this point where we check 2.1, 1.9, this interval, it is always better when we have it as small as possible, that is like 2.1. 2.01 will be much better than 2.1. 2.001 again will be more preferred to 2.01. 2.0001 will be more preferred to 2.01. That means the more closer the interval, the more smaller the interval, better for us, because it will give us more accurate values. Even with decimals also, the more decimals you have, the more accurate the values, isn't it? So 1.99 will be better than 1.9. 1.999 will be better than 1.99. So the smaller the interval, better for us. So now what we do is, but for this kind of questions, we cannot go on doing for different values and then find the values, isn't it? Like that, approaching 1 from the left hand side, so like 0.9, 0.99, 0.999, 0.99, we can't do that. So in general, what we do is, we take for a limit interval that is h tends to 0. This is an interval. Okay, this is just an interval. Okay, interval which is very close to 0, very small. Value of the function x1 minus h. 1 minus h. This simply means, I'll show you exactly what it means. You will understand, don't worry. Very small, that is like, so if we approach 1 from the left hand side, it's going to be like 0.9, for example. That means our interval h here is 0.1. So that means h is very small. So if h is 0.1, then 1 minus 0.1. So that's like checking at 0.9, isn't it? That means it's same as checking at 0.9 only, right? F of 0.9. Similarly, maybe more closer values like 0.99. So this is 1. So this is 0.99. This is 1. So what is the interval here now? 0.01. So interval is 0.01. So h is 0.01. So our value is 0.99. So it's just about that, but this is general. No, we are not finding out for 5, 6, 7 points, different points. We don't have time for that. So in general, we simply represent it by this. We simply represent it in terms of interval, that is 1 minus h. I hope you have understood that point. That's why it's written here. H tends to 0. Very small interval. Not 5, 6, 7, 8 and all. Towards 0. Very small. After that, what we do is we simplify the function. After that, it's simple. H tends to 0. F of 1 minus h. Forget about this. Okay, this means like 0.9. 0.99. 0.999. I mean this one. Not 0.9. 0.999. That simply means that only. Now, for something that is less than 1, which function are we going to use? This one or this one? It's clearly given here. When x is greater than 0 and less than 1, this function obeys this. That is 1 plus x squared. So it's going to be 1 plus x squared. But what is x here? It is 1. Because this was for f of x. Now this x will be replaced by 1 minus h. So 1 plus 1 minus h whole square. So we'll simplify that a bit. Okay, so I'm going to rub this off. Okay, I hope you have written that. So I'm going to rub this off. And then, so that's going to be limiting value as h tends to 0. 1 plus 1 minus 2h plus h squared. So that's going to be limiting value as h tends to 0, 2 minus 2h plus h squared. So now, of course, I forgot to tell you the one basic concept, that is, in the beginning, of course, I told you that the limiting value of a function, we do not put in the value of x directly like that function, no? This is something like a working rule. X tends to 2, x squared minus 4 by x minus 2. So here, if we put x equal to 2, you get what? 0 by 0. So in that case, I showed you another form, that is, maybe we can simply, so as long as we are getting 0 by 0, we will not put x equal to 2. Alright. What we do, we simplify that, we got x plus 2. So x plus 2, when you put x equal to 2, you get 4. Again, I repeat, what does that 4 mean? That 4 simply means that it is approaching towards 4 only, not exactly 4. Alright, I hope you remember that, no? So it might get a bit confusing, but please watch the video over and over again. It just talks about approaching, not exactly that particular value. So one working rule behind limits is how do we remove this limit value just to like get the answer, the mathematical value. That is, you can now substitute the value of this h equal to 0, tends to 0. I mean, you can replace it by h equal to 0 in the function. That means you can remove this limit if you are sure that you are not getting 0 by 0. Not defined, no problem. 0, no problem. You can directly substitute. If you're getting 0, do it. You're getting not defined, that also no problem, hoga. So only thing is that you are not supposed to get 0 by 0. So as long as you're not getting 0 by 0, you can just now, once it is simplified, you can just remove the limit. That is h equal to 0. Now you can substitute here. So I am removing the limit now in the next step. So it's going to be 2 minus, or substituting the value of h equal to 0 plus 0 squared. So what do we have here? We have here only 2. So the value is 2. So that means this function, as x approaches 1 from the left hand side, this function will approach towards 2, which is quite clear, which is approaching towards 2. Alright, so that's it. Now let's check for the value of the function at x equal to 2. I mean from the right hand limit, that is limiting value again of the function as x approaches 1 from the right hand side. So here also same concept, that is for a very small interval, it's going to be f of 1 plus h. This time small interval 0.1, same again. So 1 plus 0.1, 1.01, because you're approaching from the right hand side. So 1.01, 1.001, 1.0001, something like that. So in that case, so 1.1 plus something, that's like 1.01, is always greater than 1. So we're going to use this function here. So that will be limit as x tends to 0, 2 minus, what is x here? 1 plus h. The function is replaced. So that's going to be, I will remove the limit here directly now, because I'm not getting 0 by 0. Definitely 1 plus 0. So I have 2 minus 1. That is like, what do I have here? 1. So that's how we calculate the right hand limit, and that's how we calculate the left hand limit. I'll be doing more problems in the next videos again. We will be solving exercises also. So that was the right hand limit, left hand limit. There was one question again, prove that the limiting value of the function at x equal to 1 does not exist. Very clear, because left hand limit, if I remember correctly, we got 2. Here what we get? 1. Since limiting value of the function as x approaches 1 from the left hand side is not equal to the limiting value of the function as x approaches 1 from the right hand side, the limit does not exist. Alright, so if you have liked this video, please do like the video and share, and please don't forget to subscribe. Alright, then see you in the next video with more problems on limits.